So continuing on chapter 10, talking about surveys, and we finished the last video talking about parameters in statistics. So parameters, again, to review, is a number associated with the population, and then a statistic is a number that is calculated from a sample. So those are the differences, and we could have the mean of a population, we could have the mean of a sample, and so on. So let's look at a couple of examples. We're on page 3 in the notes. So in order to determine the average GPA of all students, a class was selected at random, and the GPA of the students enrolled in the class is used to estimate GPA. The average GPA of the students selected was 2.56. So the population here, the larger group that we're wanting to learn about would be all Georgia students. And then the sample would be the selected class. And then the parameter, that would be what are they trying to estimate from the population? And so that would be GPA, average GPA of all Georgia students. And then the statistic, that would be the number that is calculated from the sample. That would be, and maybe we should add the mean or the average GPA of the selected class. And so that's the idea here. Another example, research group selects 10 different tires. Where did my mouse go? Sorry about that. A research group selects 10 different tires, tries to determine the tread life of the tire. The tread life of all tires is 48,000. So here we have all tires would be the population. Whoops, the marker there. All right. All tires. The sample would be the 10 tires that were selected. The parameter would be the tread life. And probably we could say average tread life of all tires. And then the statistic would be the tread life of the 10 tires. And we'll go back up and do it with this one also, but 48,000 miles, would that be a parameter or a statistic? So this is 48,000 is tread life of all tires, average tread life of all tires. So that would go with the parameter. So that comes from the population. And then if we go back up here, I forgot to do this with this example. The average GPA of the student selected was 2.56. So that would be the average GPA of the sample. So that would be the statistic, 2.56. All right, moving on to the third example. We have nearsightedness occurs in 12% of all children. A school district has registered 170 incoming kindergarten children. Out of the 170 children, 11.76 are nearsighted. So the population would be all children. The sample would be the 170 kindergarten children. We'll just say kindergarten kids. And the parameter would be nearsightedness. Let's say nearsightedness in all kids. And the statistic would be nearsightedness in the 170 kids. All right, so now we have two numbers in this one besides the 170, which is obviously the sample size. We have 12% nearsightedness in all kids, so that would be the parameter. And then 11.76 would be the statistic because it's 11.76% of the sample. All right, moving on to the next page. So now we're going to get into a few different types of sampling methods. And so the first one is just very basic, simple random sample. And so this is where every possible sample of whatever size we want to draw has an equal chance of being selected. This is just a completely, truly random sample. Ensures that a non-representative sample is unlikely to occur, guarantees each person has equal chance to be selected. And in this case, compared to the ones that we're going to look at, each combination of people has an equal chance of being selected. Um, so there's not one group that's any more likely to be selected than the other than if they're more, abundant in the population, let's say. So this one is just, you can think of it as abbreviated SRS. You could just think of this as completely random, and you'll see kind of how that compares to other methods that we're going to look at in a minute. Sampling frame. This is not a sampling method. So this sampling frame is just a list of all individuals from which the sample is drawn. So it could be the population. It could be a subgroup from the population. We'll talk about how we might be able to get those as we go along. So deciding on sampling frame can be difficult. If you want students at this college, do you include the part-time students, online students, students that are on leave for a semester, studying abroad? So not all the students are on campus, not all the students that are on campus are full-time. So are you going to include those? And basically the sampling frame, how are you going to get your sample? And then any of the students that are in, once you kind of decide how you're going to go about it, all the students that would be on that list, if you made a list, that would be your sampling frame. And then sampling variability, we kind of talked about in the last video. So if you remember from page 1, where we had the 2 samples, and the numbers were not exactly the same, although they were similar. So that's sampling variability. So as you take samples, the numbers are going to be a little bit different from sample to sample, and doesn't necessarily mean anything's wrong. It's just completely natural that every sample is not going to look the same. So that's all that means. All right, so stratified random sampling is the first real sampling technique that we'll look at. Simple random sample is a sampling technique, but it's very basic, so it doesn't take much to understand that one. And none of these are too difficult, although once we get, I think we'll have 4 of these all together. 5 if you count census, 6 if you count multi-stage. You want to make sure that you're keeping these straight in your brain. So stratified random sample is where you divide the population into groups called strata. And I always emphasize that these are not random groups. So you could divide male, female, you could divide into group by race or religion or major, if we're talking about college students. Or if you're looking at a company, you could divide by salespeople or management and accounting and whatever else. So these are not random groups, but you're dividing the population into groups, and then you're getting some from all the groups and proportionate amounts. So if you have more salespeople than accountants, or salespeople more than human resources, or whatever it is, you would get more salespeople from your randomly after you divide into groups. So in this example, want to learn how students feel about building a new stadium. 6% of the students are athletes, so we're going to get a random sample of 50. Then we want 6% of our sample to be athletes. So that'd be 3 athletes, selected random, 47 non-athletes. So basically you divided the student body into athletes and non-athletes. You get a proportionate amount of athletes and non-athletes. So benefits estimates will be more precise. So you're more likely to have this. If you do a simple random sample, for example, you could get 25 athletes and 25 non-athletes. So that may not be likely, but it is possible with a simple random sample. So with stratified, that's not going to happen. And so that's one benefit. Reduced sampling variability because of that, because estimates will be more precise, and groups will be more divided up as they are in the population. All right, the next method is the cluster sample. And so again, we're going to divide into groups called clusters. Now they could, although not likely, but they could be the same groups that you'd use in stratified, although not likely, but you're still dividing into groups. They're not random groups. They're kind of strategic groups, but natural groups. And we call these clusters. Select one or a few clusters, draw a simple random sample or a complete census within the cluster. So we want to get the advertised average starting salary that are offered to graduates from the school. Stratified by major, so divide everyone by major, or select a few dorms. If each dorm is representative of the distribution of majors, then each dorm is a cluster. And so I don't know that, so stratifying by major, so that's the key word there. So that would be doing a stratified random sample. That'd probably not be a good way to do a cluster sample, because if you do a cluster and you divide by major, then you would select a major, say accounting, say chemistry, say art history, or something like that. And then you would ask all the art history majors or whatever major you've selected and try to get the average salary. Well, obviously average salary, changes based on the major. So it would not be a good idea to cluster by major, but you could stratify by major. It would be a better idea to cluster by dorm, because in dorms you likely will have different majors, and so you can get one dorm and get all the different majors. So that's kind of the difference. So if you need to go back and listen to that, it's completely understandable, because stratified and cluster are very similar. Benefits of cluster sampling can be less expensive and take less time, especially when the population is spread out. So another example could be if you want to find out the average high school GPA or whatever it is of all Florida college students. A natural way to divide the Florida college, I'm talking about over all the colleges, universities in Florida. A natural way to divide that would be by university. So divide up by school, and then if you're doing cluster, then you can just go to one school or a couple of schools and sample all the people in those schools, or do an SRS from those schools. As opposed to stratified, if you divide by school, then you have to go to every single school. So you have to travel all through the state. So cluster in that case would probably be easier, because you don't have to go to every school. You don't have to go over the whole state, although you could go to a few schools throughout the state, but you're not going to every school in the state as you would with a stratified. So to kind of summarize those two, both these are dividing the population into groups. Stratified, you select some from all the groups. So that's kind of we're going to switch these two. So some from all the groups with stratified, or all from some of the groups with cluster. And so that's the main thing. So with cluster, you could still do SRS. Don't necessarily have to get all, but the main part is stratified, you go to all the groups. Cluster, you go to some of the groups. So those are the two that are pretty similar, at least on the surface when you're first looking at these. So try to figure out a way to make sure you can tell the difference. So then we have multi-stage. Multi-stage combines several methods, and we're going to see another method in a minute that could be in here. So the campus has several dorms, each with alternating women's and men's floors. You want to determine what % of students like the dorm food. So we can stratify by sex, men and women. We can select one or two dorms at random. Select the same number of dorms at random from among floors that house men and floors that house women. So that'd be start with a stratified, go to a cluster after that, and then SRS on the residents on the selected floors. So we start with stratified, and then this one is kind of doing a cluster. SRS, I guess you could say, is a third level, but SRS can be included with cluster. But that's the idea. So if you have a bigger population that can be kind of pared down a little bit, you might want to do a couple of these methods before you actually get your sample. And there's multiple ways to do it. I mean, multi-stage, in any given example, you can come up with 2 or 3 different ways to do multi-stage, just depending on the order that you decide to pare it down. So then we have, let's go back, systematic. So systematic is usually very easy to identify, choosing every nth individual. So you survey every 10th person, test every 50th car. So you can pick whatever number you want, and then so the number you pick is random And then after that it's systematically selecting the people. So to see a couple of examples here. So we need to survey a random sample of 300 passengers on a flight from San Francisco to Tokyo. Name a sampling method described below. So the first one we're going to pick, every 10th passenger as people board the plane, that would be a systematic. So again, those are usually pretty easy to usually have this every whatever, and that will tell you a systematic. So those are usually pretty easy to identify. From the boarding list, randomly choose 5 people flying first class and 25 of the other passengers. So here we have divided in groups. So we have first class, we have other classes, coach and whatever. And so we're getting some from each. So we have some from the first class, some from the others. So this would be stratified. So we divide into groups and we get some from all the groups, in this case 2, each of the groups. Randomly generate 30 seat numbers, survey the passengers to sit there. So if you're just randomly generating numbers and there's no dividing into groups, that will be SRS. And then randomly select the seat position and survey all the passengers in those seats. That would be cluster. All right, so there are your sampling methods. So the sampling methods basically are SRS, stratified, cluster, systematic, and then we talked about census in the last one. That is sampling everyone, which is not common to do that. And then multi-stage is just combining 2 or more of those other methods. So again, this chapter has a lot of vocabulary. We'll have another video about different biases and different bad sampling methods that we could talk about. So we'll stop there.